do some operations, some basic operations with fractions. We're going to primarily look at addition for the moment, and it's going to require us to look at a number of different ideas. So as we start to build up an understanding of adding and subtracting fractions, we want to think about all the other things that involved in this process. I will also say that this video is primarily designed to help people who already have a background in mathematics become better at that mathematics. And this is really geared and aimed after people who are going to be teaching this particular concept. So there's a little bit of that stuff built in, like how and why we want to know this stuff. But with that said, this should be useful to anyone who wants to learn more about adding fractions. So when we look at adding fractions together, the first thing we need to do is, mechanically, we need these two numbers right here to match, the 6 and the 4. These are our denominators. And those denominators need to match. It's the number that dominates the fraction, is what is typically said. But more to the point, this is how many parts we have when we break something up. So if we have a whole of something, what we have is 6 pieces, or 6 parts rather, of that whole thing. And we have 5 pieces, which is my numerator here, of those parts. Okay? So let's just think of this in terms of a rectangle. And I have 6 of them. There we go. I am now going to point out that we have 5 of those pieces. Okay? So what does it mean for it to have 5, 6? It means that we took a whole, we broke the whole up into 6 pieces, 6 parts, and we have 5 of those parts. Those are our 5 pieces. So we have 5 pieces of 6 parts. That's 5, 6. So look at 3/4. So I'm going to do my best to draw these so they are more or less the same size. We're going to pretend that they're exactly the same size, right? And I could have drawn this a lot better. In fact, you know what? We probably should, because the problem we're going to run into when we do this is, how are we going to manage this? So I'm actually going to go across this way for a second, like this. And there's 1, 2, and 3. There's 3/4. This is going to create problems for us. I'm actually going to go back. Let's redraw this one. And you'll see why here in a second. Let's get rid of that. I guess I could have left some of them, but what I'm going to do here, I'm going to cut this in half, and I'm going to do that like this, and kind of create these thirds of sections here. Now I have 1, 2, 3, 4, 5, 6. Now I drew them in different directions because the thing that I can now do, if they're drawn in different directions, is I can kind of overlay them on top of each other. Because the problem I'm going to run into is this piece right here is not necessarily the same as this piece. They're not the same size necessarily. They could be, like if these were both squares, okay, yeah, but these weren't drawn to be squares. These were drawn to be rectangles that are the same size. So they both represent a whole and the same size whole. But the parts themselves represent different quantities. So what we need to do is I'm going to split this here, here, and here. And then I'm going to do here, here, and here like this. And now they're the same. I have the individual parts themselves are the same. And I've also changed the number of pieces I've had when I split this up as well. So when I go back and I look at my fraction here, the thing I need to do is I need to think about, how do I make these, get both of these fractions into equivalent forms so that their parts match, which is what I did over here. And you think about what I did here is I took the 6 and divided each 6th one up by 4, right? So I drew 3 lines, so 1, 2, 3, 4. Each column that represented 1/6 is now split into 4 pieces. So over here I'm going to multiply by 4. Because now I have 4 times 6. That's simple multiplication, which gives me 24. And if you count these out, you'd see, you can pause the video for a second and see, if you count these things out, you get 24 of those in there. But the thing is, remember, when we drew those lines, we broke up each individual piece that we already had into 4ths as well. And we had 5 of them, and we broke each of those up into 4s. So this 5 also gets multiplied by 4. So now I have 20 of those. And you can pause again. You can count those up and see that we have 20 that are shaded in. The same thing happens over here, except over here what I did was I drew these things vertically, and I broke each of these 4ths up into 6 pieces. So there's times 6 of them as there were before, because each one now has 6 as opposed to being one of them in there, which is why I'm multiplying by 6, right? Now the thing is, that's what I did to the parts, but my pieces I also broke up into 6. So now I had 3 rows of these, and each row got broken up to 6. So now I have 6 times as many pieces in each row as I did before. So now I can move forward with this process. 4 times 5 gives me 20. 4 times 6 gives me 24. You can count both of those and see that both of them have 24 parts. That's the total number of things inside the rectangle. And each of them have, and the top one has, the top one has 20 pieces in it that are shaded. The bottom one, which was originally 3/4, 3 times 6 gives us 18. You can count those and see that we have 18 shaded pieces inside there over 24. So now I do 20 times 18, which gives me 38 over 24, right? And if you count all these pieces up, you're going to find there's 38 in there over 24. Now, there are different ways we can write this, right? So now we're into this place of talking about common factors between the numerator and the denominator, so we can reduce this. We're also talking about whether we could rewrite this as a mixed number rather than an improper fraction. And you'll see literature where this is, instead of calling this an improper fraction, it's called a fraction greater than 1. I think both of those are fine definitions or words to put with this. I prefer improper fractions, but you do need to take some time and make sure that whoever you're explaining this to understands that improper fraction means just simply the numerator is larger than the denominator. There's nothing wrong with this. There's nothing wrong with writing it this way. Nothing wrong with 38 being larger than 24. All we're doing when we say it's improper is we're pointing out that the numerator is more than a whole. That's really all we're doing when we say something's improper, is more than a whole. Right? So this is larger than 1. So that's essentially the same thing when we talk about this being in math. So what we can do now is we can see that both of these end in even numbers. So I can divide both by 2. So if I divide the top one by 2, I divide the bottom one by 2, the numerator by 2, the denominator by 2, I end up with 19 over 12. All right? So that's an equivalent fraction. Which one's more correct? Yes, they're both equally correct. Okay? What else could I write this as? Well, I could also write this as, well, 12 would go into 19 one time with 7 left over, so it's also 1 and 7/12. So of these 3, which one's the most correct? The answer is yes. They're all equally correct. 1 and 7/12 is equal to 19/12, which is also equal to 38 over 24. And to reiterate this, because I get this question a lot, it's like, well, which one do we need to put down as the correct answer? Which one's correct? All 3 of them. All 3 of them should be acceptable as the correct answer. What you want to do is pay attention to whoever's asking the question and say, is it in simplest form? Is it in reduced form? Is it written as a mixed number? Is it written as a decimal, which I don't even have written as a decimal up here? But which one of those are they wanting? If they just say, add the 2 fractions together, there I am, I'm done, right here. 38 over 24, that's correct. That's written as a single fraction. I did the addition that needed to be done. Write it in simplest form, 19 over 12, simplest form. Nothing else I can divide anything by there. Write it as a mixed number. There it is right there, okay? Write it as a decimal. Do this division and figure out what that decimal equivalent is. So when you write fractions, just make sure you're answering the question, but there are lots of different answers. I could have come through here, and I could have also said, you know what, I'm going to multiply top and bottom by 2, in which case I get 76 over 48. I'll let you do a little bit of the math on that. There's a 4th form that is equally correct as the other 3 that we already had. So, recap. When we try to find, or when we're trying to add fractions, the first thing we need to do is we need a common denominator. The easy one to do here, right, in this case, is just 4 times 6, which gives us 24. This isn't the only way we could have done this, by the way. Like, for instance, I could have done 5 over 6. I could have multiplied by 2 over 2. Over here, I could have done 3/4, and I could have multiplied by 3 over 3. So maybe you're like, where did all those numbers come from? 2 times 6 is 12. 4 times 3 is 12. So what I have here is 10 over 12 plus 9 over 12, which is 19 over 12, which is what I got right there. So it's just another way of reworking the exact same problem. Instead of using just a common multiple to get there, whatever the common multiple it was. In this case, it's 24. I used the least common multiple, which in this case is 12. They both give you the correct answer. Neither one's wrong or better. The numbers are smaller here. That doesn't make it necessarily better. It really means that what matters the most is that you understand the process you're doing. This makes sense. This should also make sense. Do over which works best for you. All right, I hope you enjoyed this. I hope this helped you understand addition of fractions a little better. And keep doing math.